power or power, whichever way you want to pronounce it. So the definition is power is the rate of doing work. So power formula is work done divided by time. And we know the basic formula for work done, that is F into S into cos theta. So if we put that formula in place of work, so power will be Fs cos theta divided by time. And now if you look at this expression, S stands for displacement and T is the time. And displacement upon time is nothing but velocity. So the expression of power will become Fv cos theta. So in the exam situations, either we can use the basic formula for power, which is work done per unit time, or we can write Fv cos theta. So this is one approach of finding the power. But there is another formula to find the work done, and that is by the work energy principle. So we know the total work done by all the forces acting on an object, that is equal to the change in the kinetic energy. So instead of work done, we can put delta K. So the power formula comes out as work by time, which is also equal to change in kinetic energy divided by time. And now we can summarize all these formulas in one. So power is work done per unit time, which is also written as energy by time, which is also written as change in kinetic energy divided by time, which can also be written as Fv cos theta. So depending on which parameter is present in the question, we can use various formulas. And what will be the unit of power? Since power is work done per unit time or energy per unit time, the unit of energy is joules and time is seconds. So either we can write joules per second or we write W. W stands for watt. And now let us try to solve a few questions based on these formulas. So here we go. Question number one. A builder uses a block and tackle pulley system to lift a bundle of materials of mass 15 kgs to the top. So the height is 6 meters, time taken is 9 seconds. We have to find the power delivered to the bundle. So let us write down the basic formula for power, which is work done per unit time. Now, how do you find work in this case? So the basic formula for work done is equal to F into S into cos theta. But in this question, they have not really specified what is the value of the applied force. So this formula of work will not be useful. Now, work can also be figured out using the work energy principle, which is change in the kinetic energy. But the question has also not specified any initial and final velocities. So what do we do in such cases? So remember, whenever work is done, it is energy transformation taking place from one form to another. Let's focus on this bundle of materials. And let us say if I draw a dotted line, let's consider this as our reference line. Now, reference line, if you recall, this is the point where the gravitational potential energy is taken to be zero. Now, it is said this entire mass, which is of 15 kgs, is taken up. Let me draw a diagram. So, taken up to a height of h, which is given as 6 meters. Now, if you analyze carefully, it is the gravitational potential energy which is changing. Initially, it is zero, and finally it has been taken to a height. So the new potential energy will be mgh. So instead of work done, we will write the change in the gravitational potential energy. So when this entire mass is lifted up to a certain height h, which is 6 meters, so the work done will be written as mgh, and time is in the denominator. So that's it. Let's put all the values in. Mass is 15 kgs, g we can take as 10, height is given as 6 meters, and time is mentioned as 9 seconds. And if we simplify this expression, we will get the value of power as 100 joules per second, or we can write that as watt. And that is why option C will be the right answer. Next, we have a box which is pulled by a child with a horizontal force of 5 newtons. So let's draw a diagram. Consider this is the box which is being pulled towards the right with a force of 5 newtons. The box moves a horizontal distance of 4 meters. So displacement is 4 meters and time taken is 2 seconds. We need to figure out the average power which is delivered by the child to the box. So let us start with the basic formula for power, which is work done per unit time. And how can we find the work done? We can use the basic formula Fs cos theta divided by time taken. In this question, they have clearly mentioned the force as 5 newtons, displacement is 4, and the angle is 0 degrees. And why 0 degrees? Because the force is towards the right side, and even the object is moving towards the right side. So the displacement S and the force both are in the same direction. That is why the angle is 0 degrees. And in the denominator, the time taken we can use as 2 seconds as it is given in the question. And that's it. If we simplify this, we will get 10 joules per second or 10 watts as the answer, which means the answer is option C. Now, there is one more alternative to solve this question. So, instead of work done upon time, we are going to use the formula FV cos theta. So, theta is 0 degrees, cos 0 will be 1. So, power will be written as F into V. Now, force is mentioned as 5, but V stands for the velocity, which the question has not given. But we can figure out the value of velocity by using the basic formula for velocity, which is nothing but displacement upon time. Displacement is given as 4 meters, time is 2 seconds. So velocity comes out as 2 meters per second. And we can put this value of V over here. So F into V. So 5 into 2 will get us 10 watt as the value of power. Option C is the answer. Okay, so in this question, we have an engine of a racing car which is providing a forward thrust of 800 newtons. So let's draw a diagram. Consider this is the car and the engine is providing a forward force of 800 newtons. Now it is mentioned that there are resistive forces present in this case. So the average of the total resistive forces acting on this car is 300 newtons. Now since these forces are resistive, so the direction of force will be opposite to the applied force. So applied force was towards the right hand side. So the resistive force will be towards the left hand side. So 300 newtons to the left. And now they have mentioned that the car is covering a total distance of 1 kilometers in 10 seconds. So let's draw. The car is going, let's say, towards the right hand side. It travels 1 kilometer. Now let's convert 1 kilometers into meters. 1000 meters is the total distance covered and the time taken is 10 seconds. And we need to figure out what is the power. But while solving such questions, be very careful about the keywords present in the question. So the question is asking us to find the power of the engine only, which means we are not supposed to consider the resistive forces here. So let's write down the power generated by the engine will be equal to the work done divided by time. Now we are only focusing on the engine, so we are not going to consider the resistive forces. So for the work done, we will use the basic formula Fs cos theta divided by time. Force, which is provided by the engine, is 800 newtons multiplied by the distance traveled is 1000 meters. Let's write that down, multiplied by the angle theta will be 0. And why is it 0? Because the applied force is towards the right and even the displacement is towards the right. So they are parallel. That's why we take angle as 0. In the denominator, we can write down the time which is given as 10 seconds. And that's it. Now, if we simplify this, we are going to get 8 multiplied by 10 to the power 4 joules per second or watts as the answer. So this is the power which is generated by the engine. And if we look at the options, it is option D, which is the correct answer. So here we have a boat which is traveling along a straight line for a total duration of 1 hour. The boat travels at a constant speed and covers a distance of 2.4 kilometers. The thrust provided by the boat's engine is 1.8 kilonewtons. And we need to figure out the energy exerted by the boat's engine in 1 second. So let us draw a diagram and tabulate all information which is given in the question. So first they are saying that the total time of travel is 1 hour. So let's write down total time is 1 hour. Let's convert that into SI units, which is seconds. So 1 hour will have 3600 seconds. That's 1 hour. Next, it's mentioned that the boat is traveling at a constant speed and it is covering a distance of 2.4 kilometers. Let's convert 2.4 kilometers also in meters. So that will be 2400 meters. Next, they have specified that the thrust of the boat's engine is 1.8 kilonewtons. Now, 1.8 kilonewtons is 1.8 multiplied by 10 to the power 3, which will be 1800 newtons. So in the diagram, I can draw a rightward applied force F, which is provided by the boat's engine, that is equal to 1800 newtons. Now the question is, we need to figure out the energy exerted by the boat's engine. And how do we do that? We are going to use the power formula. Power is work done per unit time, which is also written as energy divided by time. And if we make energy as the subject, we will get power into time. Now, the question is, we need to find the energy exerted in 1 second. So, this T value is clearly 1 seconds, which means we need to identify the value of power. So, now let's use the basic formula for power, which is work done per unit time. So, power is work done per unit time, and work is Fs cos theta divided by time. So even in this case, the angle theta will be equal to 0 degrees because the boat's engine is applying a thrust force towards the right and the boat is also moving in the same direction. So the angle theta will be 0 degrees. So power will be equal to F is the applied force, which is 1800 newtons. Let's write it down. And the displacement is 2400 meters multiplied by cos 0. And the total time of travel was 1 hour, which is 3600 seconds. So in the denominator, we will write 3600. If we simplify this expression, we will get the value of power as 1200 watts. So this is the value of power. But the question wants us to find the value of energy. And how do we do that? Energy is equal to power into time. Time is 1 seconds, as they have mentioned in the question. So the value of energy will be power is 1200. Time taken is 1 second. So that will be 1200. Now the unit is important. We are dealing with energy. So it will be 1200 joules. Now let's look at the options. 1200 joules means 1.2 kilojoules, which is in option B. And that's why option B is the correct answer. So this is a graph-based question. We have been given there is a motorized toy car starting from rest. So let's write down initial velocity will be equal to 0. And in the graph, x-axis is time, y-axis is power. The power which is delivered by the motor is increasing. That's not a constant. And the question is assuming no energy losses, which means there are no resistive forces. Which of the following gives the kinetic energy of the car after 8 seconds? Now let us start with writing the basic formula for power. Power is work done per unit time. But please remember, any formula of physics can only be applied if all the parameters involved are constant. So in this case, they have mentioned that power is increasing. Also, you can see in the graph, power is increasing at a constant rate. Now, since power is not a constant, we cannot apply this formula, the basic formula of work done by time. So how do we deal with such questions? So remember in physics, whenever you have a graph based question, either your approach should be the gradient of the graph or the area under the curve. How do we determine the right approach? So the way to do it is, let us try to isolate the term which we have to identify. So the question, we have to find the kinetic energy of the car after 8 seconds. So basically we need to figure out the energy. So power is also written as energy by time. So let us make E, energy, as the subject. So we will get power into time. Now this formula will help us identify the right approach. So on the x-axis, we have time. On the y-axis, we have power. So let me write P, power is y-axis and time T is the x-axis. So which means the x and y are getting multiplied together. And that is the hint. If x and y are getting multiplied together, you will do area under the graph. But in another question, let's say we were able to deduce y divided by x. So division. Whenever division exists, then we do gradient. Now, in this case, it is multiplication of the x and y axis. So we will find the area under the graph. And how do we do that? So we go to the end point of this graph, which means over here, and we draw a dotted line towards the time axis, which in this case is the x axis. So we draw a dotted line perpendicular to the time axis, and then we have to figure out the area of this entire shaded region. So this is nothing but a triangle. Area of a triangle is half base into height. Now the base of the triangle, you can see it is 8 seconds. Let's write it down. And multiplied by what is the height of this triangle? That is about 40. So this is half into 8 into 40. And if we simplify this, we will get 160 joules. So 160 joules is in option C. So before we mark option C as the answer, we need to be careful about one thing. And that is the initial velocity. So although power is work done per unit time, which is energy per unit time, remember the basic concept of work. Whenever work is being done, energy is transformed from one form to another. So in this case, initially the car was at rest. So initial kinetic energy is 0 and final kinetic energy will be some non-zero value, of course. So the 160 joules, which we have actually identified, let me write, this is actually the change in the energy, which can be written as the final energy minus the initial energy. Now, the question has clearly specified that the car is starting from rest, so initial kinetic energy will be 0. And then we can write 160 is equal to final energy minus 0. So, final energy will come out as 160 joules, which is option C.